Greetings to all technology geeks and science enthusiasts. Welcome to Science News Monthly Highlights. Here we delve into scientific breakthroughs of April 2024. Let's start with neuroscience news first. Researchers from the University of Tokyo have developed a technique to connect lab-grown brain tissues, mimicking the complex networks found in the human brain. By linking neural organoids with axonal bundles, they observed sophisticated activity patterns resembling natural brain functions. This breakthrough enhances our understanding of brain network development and offers promise for studying neurological disorders and developing better treatments. Meanwhile, engineers at Rice University created the smallest implantable brain stimulator, powered wirelessly by magnetoelectric technology. Named the digitally programmable over-brain therapeutic DOT, this pea-sized device offers a less invasive alternative for treating drug-resistant depression and other neurological disorders. It can stimulate specific brain regions through the protective membrane of the skull, potentially improving patient autonomy and accessibility to therapy. The device, which received successful temporary testing in a human patient and stable usage in pigs, could be used from home with a simple, wearable device for power and control. This innovation may revolutionize mental health treatments, offering a minimally invasive and effective solution compared to current options. Our third highlight comes from Nature Human Behavior, where research published a comprehensive meta-analysis of touch interventions, involving 13,000 individuals from more than 200 studies to determine their effects on physical and mental well-being. Touch interventions showed significant benefits, including reduced pain, anxiety, depression, and stress in adults. Surprisingly, the person delivering the touch, the method, and the duration did not significantly impact the intervention's effectiveness. However, the frequency was crucial, with more frequent touches yielding greater benefits. While human touch was generally effective, object or robot interventions also improved physical well-being, albeit less effectively for mental well-being. Lastly, Gabe Newell, the head of Valve, has been quietly developing a brain-computer interface startup called Starfish Neuroscience since 2019. In April, the company updated its website, generating excitement in the community. The company aims to create minimally invasive wireless sensors and actuators for BCI applications, potentially including gaming, similar to those pursued by Neuralink, Elon Musk's company. Details about the specific technology developed by Starfish are still limited. The company's freshly updated website features a photo of what seems to be its custom brain chip, which appears to be smaller than Neuralink's larger coin-size implant. Now, delving into robotics news. First up, engineers from Hong Kong have developed a hopping drone by attaching a telescopic leg to a quadricopter. This innovation enhances flight time and payload capacity, as the drone can hop when needed, reducing battery drain and allowing for heavier loads. The drone can move smoothly between hopping and flying, and it's capable of hopping vertically, horizontally, and on uneven ground. With applications ranging from wildlife monitoring to disaster assessment and agricultural monitoring, this agile drones offers versatile functionality in various scenarios. Furthermore, inspired by Star Trek's holodeck, engineers have created the holodeck, a system for generating interactive 3D environments using language commands. Leveraging large language models such as ChatGPT, holodeck interprets user requests to create custom environments, complete with objects and layouts. Researchers demonstrated holodeck's superiority over previous tools by generating scenes and having students rate them from realism and preference, with holodeck consistently outperforming Procthor in asset selection, layout coherence, and overall preference. Google's DeepMind team has employed machine learning to teach tiny robots to play soccer, marking a shift from traditional direct programming approaches. These robots, standing at around 510 millimeters tall, exhibit impressive soccer skills, including strategic maneuvers like feints to outmaneuver opponents. The AI-trained robots surpass their counterparts trained using other methods, showcasing the potential of machine learning in robotics. And last but not the least, a three-legged robot called the Space Hopper, developed as a student project at Zurich University, has been tested for exploring asteroids. Equipped with deep learning-based software, the robot can perform various functions, such as hopping, maintaining orientation, and controlling landings. It utilizes its legs to launch high off the surface, maintain balance in flight, and absorb impact upon landing. Recent tests on a zero-gravity flight demonstrated its capabilities, showcasing its potential for efficiently exploring low-gravity celestial bodies. Now let's discuss things happening in astronomy and space exploration. So, on April 8th, a total solar eclipse was visible across Mexico, the United States, and Canada, providing millions with a spectacular view of the sun's corona. Viewers witnessed planets like Venus and Jupiter, as well as pink prominences, visible to the naked eye due to the eclipse. Astronauts aboard the International Space Station observed the eclipse shadow on Earth from 261 miles above. Mainly total solar eclipses provide scientists with opportunities to study the sun's corona, aiding in the research of space weather and advancing our knowledge of exoplanets in other planetary systems. In other news, NASA aims to establish a unique timekeeping system for the Moon due to its slightly faster time progression compared to Earth, 58.7 microseconds quicker each day. The initiative involves creating a Moon-centric time reference framework distinct from Earth time zones. A preliminary plan is expected by the end of 2024 and a finalized version by 2026. This effort aligns with NASA's goal of sending astronauts around the Moon in September 2025 and landing on its surface by the following year. Moreover, NASA's Kennedy Space Center is developing electrodynamic dust shields (EDS) technology to mitigate the hazard of abrasive lunar dust for moon missions. Using transparent electrodes and electric fields, EDS can remove dust from surfaces like thermal radiators and spacesuits. Tested in space and planned for lunar landed missions, EDS could be crucial for future Artemis mission, potentially extending human presence on the moon and simplifying tasks by reducing the need for cleaning supplies. Next, new model calculations by researchers at the Max Planck Institute for Solar System Research reveal that a star's magnetic field significantly influences the interpretation of exoplanet characteristics observed by space telescopes like Kepler and James Webb. The brightness distribution of a star's disk, determined by its magnetic activity, impacts the signature of exoplanets in observational data. This underscores the necessity of considering stellar magnetic fields when analyzing data from the latest generation of space telescopes focused on distant exoplanets. The findings highlight the importance of accurate interpretation of light curves, which provide insight into exoplanet size, orbital period, and atmospheric composition. Last but not the least, in October 2022, astronomers observed the brightest gamma-ray burst (GRB) ever recorded, which is a number GRB 221009A, attributed to the collapse and explosion of a massive star. Now, utilizing NASA's James Webb Telescope, our Northwestern-led team confirmed the burst association with a supernova, solving one mystery by deepening another. Despite expectations, no evidence of heavy elements like platinum and gold was found within the supernova. Instead, characteristic signatures of elements such as calcium and oxygen were detected during James Webb's near-infrared spectrograph, paired with observations from ALMA in Chile to distinguish the supernova's light from its preceding afterglow. This discovery raises questions about the origins of heavy elements in the universe. Now let's talk about nanosciences research news. Scientists at the University of Maryland, College Park, have developed a novel approach combining machine learning with molecular science to discover all-natural alternatives to plastic. Led by Professor Po-Yen Chen, the team's method involves an autonomous pipetting robot to compile a library of nanocomposite films from various natural sources. This library is then used to train a machine learning model which predicts material properties based on composition. The approach significantly accelerates the discovery of biodegradable plastic substitutes, offering customizable options with desirable properties. The team aims to expand the range of natural materials and applications while addressing issues like disposal and scalability, contributing to global efforts to reduce plastic pollution. Also, a research team has developed a groundbreaking nanotorch for imagining living cells, enabling real-time tracking of microrobots within the body. This rechargeable luminescent nanoprobe emits light for over 10 days after excitation and can be non-invasively recharged with the near-infrared light. The nanotorch consists of nanoparticles containing a luminescent organic molecule precursor, photosynthesizers, and cell-penetrating peptides. When exposed to near-infrared light, the photosynthesizer activates oxygen molecules, leading to luminescence from the organic molecule precursor. The nanotorches can be repeatedly recharged, offering a powerful tool for long-term cell tracking in vivo. A new diagnostic tool combines optofluidics and nanopore technology to create a lab-on-a-chip system capable of testing for SARS-CoV-2 and Zika virus with accuracy comparable to PCR tests, but in a matter of hours. The system requires little sample preparation, is amplification-free and label-free, reducing the time and complexity of diagnosis. It utilizes magnetic microbeads with RNA sequence specific to the virus being tested, which are then analyzed using a silicon microfluidics chip and a nanopore to detect the presence of virus RNA. The system showed accurate detection of viruses even at low concentrations, outperforming PCR tests in some cases. If commercialized, this compact system could revolutionize virology testing by providing faster results and increased accessibility. Lastly, scientists from Linköping University, Sweden, have successfully created sheets of gold only a single atom layer thick, termed goldine. This achievement was made possible by embedding gold between layers of titanium and carbon using a technique called intercalation by modifying a centuries-old Japanese forging method known as Murakami's reagent. Researchers were able to etch away carbon residue and stabilize the gold sheets. Goldine exhibits new properties such as acting as semiconductor, opening up possibilities for applications including carbon dioxide conversion, hydrogen production, and value-added chemical synthesis. As for biometrics, researchers at the Linköping University in Sweden have pioneered LED digital display technology using halide perovskite. This groundbreaking innovation integrates touch, fingerprint recognition, and pulse detection directly into the screen. Still in the prototype stage, this technology could revolutionize user-device interaction by eliminating the need for separate sensors. Moreover, these displays can also charge the device they're integrated into by harnessing light akin to photovoltaic cells. Although currently hindered by perovskite material instability with degradation after a few hours of use, scientists are optimistic about resolving these issues within a decade for mainstream use. Moving on, researchers have enhanced dense convolutional network DenseNet architecture to boost image recognition accuracy and efficiency. Their approach involves refining the model's internal structure to reduce parameters while maintaining effectiveness and optimizing parameter updates across multiple computing nodes during parallel training. This strategy not only increases the efficiency of the DenseNet module, but also enhances its image recognition performance, surpassing other state-of-art models. Scientists at Imperial College London have developed ARC2Face, a computer model for generating realistic human faces while maintaining identity consistency. Unlike other models, ARC2Face relies on identity embeddings extracted from a pre-trained ARC face network, enabling it to create a varied ARC network, enabling to face varied facial images of a single person. The model surpasses previous synthetic datasets in training facial recognition models, utilizing the WebFace42M database for comprehensive training. By ensuring diversity among synthetic identities and comparing performance to real-world datasets, ARC2Face generated synthetic data proves highly effective in training face recognition models, outperforming existing methods. Finally, Stanford University researchers have made a fascinating discovery. Their study demonstrates that facial recognition technology can predict a person's political orientation with statistically significant accuracy. Despite modest results, the correlation coefficient indicates a link between facial features and political beliefs. By controlling for demographic factors, the study isolates the influence of facial features on political orientation predictions. While intriguing, it's essential to interpret these findings cautiously, avoiding assumptions that could fuel heated debates. In the realm of green technology, researchers at EPFL have discovered that surrounding electrocatalysts with magnetic fields can enhance the efficiency of clean fuel production processes. By inducing Lorentz forces which create whirling motions, magnetic fields improve the transport of reactants and products at the catalyst surface. This breakthrough overcomes limitations posed by reactant scarcity and could revolutionize energy conversion technologies, making fuel cells more widely adopted and increasing the production of hydrogen as a clean energy source. The study provides a pathway towards more effective and sustainable fuel production methods. Meanwhile, Kobe University bioengineers, in collaboration with Kaneka Corporation, have developed engineered bacteria capable of producing a plastic modifier called LAHB. This modifier enhances the processability, fracture resistance, and biodegradability of renewable source plastics like polylactic acid. By manipulating the bacteria's genome, they achieved tunable production of LHB chains, controlling their length and thus the properties of the resulting plastic. The resulting material, when combined with polylactic acids, creates highly transparent, moldable, shock-resistant plastic that biodegrades rapidly in seawater. Moreover, the bacteria used can potentially utilize CO2 as a raw material, paving the way for synthesizing plastics directly from greenhouse gases. Furthermore, new research published in Nature Geoscience suggests that marine cloud brightening (MCB), a form of cloud engineering, could be more effective for climate cooling than previously thought. While previous models focused on the brightening effect of aerosol injections on clouds, this study finds that MCB primarily works by increasing cloud cover, accounting for 60 to 90% of the cooling effect. Using data from the effusive eruption of Kilauea volcano in Hawaii as a natural experiment, researchers observed a significant increase in cloud cover and regional cooling effect of up to minus 10 watt per square meter during periods of volcanic activity. While MCB may offer temporary relief from global warming, it does not address the root causes of climate change and should be considered a painkiller rather than a solution. Moving on to the fascinating realm of genetics, researchers of the University of Geneva have deployed a novel approach combining high-resolution microscopy and kinematic reconstruction techniques to visualize the genesis of the human centriole, a crucial organelle involved in cell skeleton organization. By leveraging expansion microscopy, they achieved unprecedented detail in observing the assembly process in 4 dimensions. This breakthrough sheds light on the intricacies of centriole formation and paves the way for studying other cell organelles, offering insights into cell function and related pathologies. Moreover, scientists have delved into the genetics of macroalgae, commonly known as seaweed, to uncover the genetic mechanism responsible for the evolution of multicellularity in these organisms. They found that multicellularity involved independently in 3 different lineages of macroalgae, facilitated by the acquisition of genes related to the cell cohesion, extracellular matrix formation, and cell differentiation. Surprisingly, many of these genes originated from viruses. By sentencing 110 new macroalgal genomes, the study sheds light on the metabolic pathways unique to the macroalgae and the genetic basis of their success, including genes acquired from viruses. Finally, a study published in Nature Communications suggests that left-handedness may have genetic underpinnings, with rare proteining altering variants in the beta-tubulin gene TUBB4B being more common in left-handed individuals compared to the right-handed ones. These variants are associated with microtubules, which play a crucial role in cellular structure and movement. While the exact mechanisms linking these variants to handedness remain unclear, previous research suggests a potential role in brain development and asymmetry. Well, as April draws to a close, we'll look back on a month brimming with remarkable scientific breakthroughs, from delving into the complexities of the brain to spearheading eco-friendly innovations. Join us in the coming month as we persist in exploring the marvel of science. Be sure to keep an eye out for future highlights. Thank you very much and have a great rest of the day.